Dear student, in this video, I'd like to show you how to find the confidence interval for the true mean. Let's see at this example I have downloaded the file called employee, and that data frame has 200 observations with 25 variables. If you click on the data frame, you can see the variables we have. So there are total of 25 variables. Now let's read the question we have. The researcher wished to estimate the average weight of employees. Construct the 99% confidence interval for the true mean weight. So here we are interested only on the variable weight. In order to find the confidence interval, we need the following information. First of all, we need to find the sample mean. Let's use the command mean. The data frame name is employee. Then select the variable weight. We need to save our sample mean in the environment so that later on we can work with it. So I will save it with a name as x bar 1 since this is question 1. So run the code, you will get the value of the mean. If you want to print this value in the environment, you can just type it again here and it will appear in the environment. Now next, we also need the sample standard deviation. So we will save the sample standard deviation under the name S1. The command used for computing the standard deviation is SD. Then we use the data frame name, employee, and then we select the variable weight. Again, we can see that the standard deviation is saved in the environment with the name S1. If we want to print it here in the console window, we can just type it again and we get. What else we need? We need to know the critical value. Before that, we need to know the confidence level we have is 99%. So it means the value of alpha, I will save it as alpha 1. And to get the value of alpha, if we have 99%, that means alpha will be 1%. We write the value of the alpha in decimal points, so it will be 0.01. So for your information, alpha is, just subtract 100 from 99, you get 1%. So 1% is same as 0.01. We also need the value of n because of the value of n, we can decide whether we use normal distribution or t-distribution. Employee has 200 observations, so n is 200. So you can store n1 as 200, or you can use the code nrow to count. Of course, the value you get is 200. So n1 is saved as 200. Now let's move to the first step of constructing the confidence interval. To construct a confidence interval, you need to get the critical value. The critical value for Z is, you need to find it using the command for the critical value of the normal distribution. The command for the critical value of normal distribution start with the code Q norm. Then, since this is two-tailed, and we want the positive critical value. The positive critical value can get it 1 minus alpha 1 over 2. Okay. Why I'm getting here as an error, alpha 1 not found, because I did not run alpha 1. So now let's see. So now alpha 1 is saved. So we can get the critical value. I will save the critical value as Z1 in the environment. Once you have the critical value, you can find the margin of error. So compute the margin of error. Margin of error, the formula we studied in the theory class, ME, is equal to the critical value times the standard deviation over the square root of n. So the same thing we will do here. We are going to save the margin of error as ME1. We have already have the critical value. We have saved it as Z1. We have already computed the standard deviation and we have named it as S1, divided by the square root of, we have saved our n as N1. Okay, I want to see the margin of error, so I can just type again. The margin of error will appear 2.80. You can round your answer into 2 decimal, 3 decimal places as per the question. Now, what is the lower limit of the confidence interval? The lower limit of the confidence interval is the value of the mean minus the margin of error. So we will take x bar. We have saved x bar as x bar 1 minus marginal error 1. That gives us the lower limit of the interval, which is 68.51574. We can round that interval also. Now let's see the next one we have here. The upper limit is x bar 1 plus ME1. So now I'm calculating the lower limit of the confidence interval. So the upper limit is 74.12326. This is regarding finding the confidence interval if your data frame or your data is more than 30. So here the data is 200, which means we are going to use normal distribution. Now let's see this question we have. Using the file employee, estimate the mean height of employee by constructing a 90% confidence interval for the height. So first of all, I need the following information. I need x bar, the sample mean. Sample mean is also known as best point estimate for the population mean. So the command is mean, the file name is employee, dollar. This time I'm going to select height. I also need, okay, what a mistake I made. I just saved the mean again as x bar 1. So the mean for the height is saved, replace the mean for the weight. Let me just save it as x bar 2. So x bar 2, and then let me just go back. So that's the previous one again, it's saved as x bar 1. Okay, so the mean for the height is saved as x bar 2 here in the environment. Now I need the standard deviation. I will call it S2. The command is SD, and then employee dollar. The variable name is height. What else we need? We need N2. It is same as N1, enroll, employee. Of course, we are going to get 200 because we have 200 data. And also we need alpha. Let's save it as alpha 2. And since you have 90% confidence interval, your alpha will be 10%. So in decimal, alpha will be 0.10. What is the critical value at 90% confidence level? Since the data frame has 200 observations and is 200, of course, we are going to use normal distribution, and the critical value will be for the normal distribution. So the command you use for critical value of normal when you have two tail, because confidence interval has two tail. So the command we use for critical value of two tail is 1 minus alpha 2 divided by 2. This gives us the positive critical value of Z. I'll save that one as Z2. And then, okay, so we have to save the alpha first. Then we can find the critical. Now, the formula for the margin of error is margin of error. For this question, I will save it as MA2. Then multiply the critical by the standard deviation of this, of the height, I mean, divided by the square root, whether you write 200 or you just name it as N2. So margin of error is saved. If I want to see it, I can just type it again. It will be printed in the environment. Find the lower limit of the confidence interval. Lower limit of the confidence interval is the mean minus the margin of error 2. So run the code, you will get the margin of error, the lower limit of the confidence interval. The upper limit of the confidence interval is similar, but instead of minus, we have plus. So that is regarding normal distribution. So use normal distribution if you have a large set of data. Now let's download, which we already downloaded the file called education. And this file, education, has 20 observations, so n is 20, and variables are 30. So estimate the true mean class size of a school using 98% confidence interval. Again, I need to get, in order to find the confidence interval, I need to find the sample mean. So X bar 3, I will call it mean for the data frame name is now education, dollar, the class size. Okay, that is the class size we have. Run the code. X bar 3 is saved here. We can print it again if we want to display it in the console window. Let's compute the standard deviation. Again, the code is SD. The file name is education, dollar, average class size. Run the code. We are getting it here, S3. If we want to print it in the console window, we can just type it again. We also need N, let's call it N3. To get the N, we use the command enroll, file name. You can take this command if you don't want to do it again and again. just take it. It's saved as N3, so N3 is 20. We need also alpha. So alpha is equal to, if you have 98%, so that means alpha is 2%. 2%, just convert your percentage in decimal, it is 0.02. Let's save it as alpha 3. So that is 98%. What is the critical value at 98% confidence level? Because you have small sample 20, which is less than 30, you have to use t distribution. The critical value for t distribution start with q t. Again, confidence interval means two tells. So again, you're going to use 1 minus alpha over 2. So it gives a positive critical value for t. I will save it as T3 because that is question 3. That is for easy for youth to determine. These are saved here in the environment. Refer to which questions. So alpha, divide the alpha by 2. If you run the code, you will not get the answer because the t distribution depend on degree of freedom. So you must enter the degree of freedom. We know that degree of freedom in t distribution is n minus 1. We can write 20 minus 1. We can write directly 19. We can write n3, which is the sample size for employee, for education, minus 1. Compare the margin of error. Margin of error, we will save it as ME3. And we compute it similarly. The critical value times the standard deviation divide by square root of N3. So if you want to display it, we can display it. That is the margin of error. Now, what about the lower limit of the confidence interval? Take the mean, the sample mean for this question, subtract it with the margin of error. You get the lower limit of the confidence interval. Again, take the sample mean plus the margin of error, you will get the upper limit of the confidence interval. So that is regarding the how to construct confidence interval or using normal distribution or t distribution. Thank you for watching.